Most AI demos show you the answer. I want to show you the audit trail. What you are seeing here is Cursor coordinating a small swarm of agents inside a real game project. The 4 terminal windows are not decorative. They are tailing the real session logs created by the Cursor agents while they work. Each agent has a role. Each agent has a session file. Each agent is inspecting a different slice of the project. And the important part is that the swarm does not end by flattering my assumptions. It finds a release blocker. That is the reason this workflow is interesting to me. Not because it makes software feel effortless, because it gives me a structured way to test whether my own evidence is still true. The project is called Run the Strait. It is a Unity tactical action game that I have been pushing through iPhone and iPad release readiness. By this stage, the work is no longer just write code and run the game. It becomes a systems problem. There is gameplay quality. There is automated mobile QA. There are Maestro flows. There are iPhone and iPad simulator runs. There are App Store privacy pages, support pages, release scripts, archive reports, screenshots, recordings, build artifacts, signing state, and a long chain of evidence that has to stay consistent. The problem is that all of those questions sound related, but they are not the same question. Does the game reach the open sea on iPhone? Does it do that on iPad? Do the reports still point to files that exist? Did the latest App Store pre-flight pass? Are we looking at fresh release artifacts or old evidence that only looks convincing because the file name has a date in it? This is where I started using multi-agent workflows in the project, not to replace engineering judgment, to split investigation into independent evidence lanes. One agent can inspect QA proof. One can inspect App Store blockers. One can inspect process hygiene. One can inspect artifact freshness. Then a coordinator can compare all 4 and make one final readiness call. That is what I am recreating in this recording. When I say swarm, I do not mean a pile of agents randomly touching the repo. That would be a good way to create noise. Here, a swarm means role separation with synchronization. There is one coordinator. The coordinator decides what questions need to be answered, launches specialist explorers, waits for their results, and then combines the findings. The explorers are intentionally narrow. They are not each trying to understand the whole project. They are each responsible for one evidence lane. The most important design rule is this: parallelize read-only inspection. Serialize anything that mutates shared state. That rule matters because this project uses Unity, Xcode, iOS Simulator, and Maestro. Those tools all touch shared state. Unity has the library database. Xcode has generated projects and derived data. The simulator has installed apps and device state. Maestro produces screenshots, videos, logs, and reports. If 4 agents inspect 4 documents at the same time, that is useful parallelism. If 4 agents run Unity, Xcode, and Maestro at the same time, that is not a swarm. That is a race condition wearing a lab coat. So this demo is deliberately read-only. The agents can gather evidence in parallel. The heavy build lane stays serialized. That is the boundary that makes the workflow trustworthy. Here is the prompt I gave Cursor. The first thing it establishes is the context. Then it defines the coordinator view. Cursor should visibly show the multi-agent orchestration, while the terminal windows show readable live logs. But I want to be precise about what those terminal windows are. They are not separate agents pretending to be the Cursor agents. They are tails of the actual session logs Cursor writes for its subagents. The next part is the safety contract. Read-only inspection only, no file edits, no staging, no commits. This is not because I distrust the agents. It is because I want the evidence lane and the mutation lane to be separate. Then I ask for 4 explorers: QA Evidence Explorer, App Store Blockers Explorer, Process Hygiene Explorer, Artifact Proof Explorer. These are not arbitrary names. They are the 4 ways this project can fool me. It can have gameplay evidence but no release evidence. It can have scripts but no fresh artifacts. It can have passing reports but missing referenced files. It can have a build plan that works only if one person remembers not to run two heavy tools at once. The final instruction is the most important one. End with a synchronized summary. The coordinator is not just collecting 4 answers, it has to reconcile them. That is where this becomes a workflow instead of a set of chat windows. Now we can look at the coordinator transcript. The first thing cursor does is state the operating model. Read-only evidence agents can inspect logs, scripts, and artifacts independently, while real Unity, Xcode, and Maestro build lanes must stay serialized. That is exactly the structure I want. In this earlier run, cursor created an agent named Plank. Plank was assigned to QA evidence. Then it created Franklin. Franklin inspected App Store blockers. Then Einstein. Einstein inspected process hygiene, and then Plato. Plato inspected artifact proof. In the Livetail recreation, the names are different: Herschel, Curie, Fermat, and Newton. That is expected. The nickname can change from run to run. The durable identity is the role, the thread ID, and the session log file. This is the authenticity layer. Each terminal window is attached to a real rollout JSONL session file under .codex sessions. The log shows the public parts of the agent run: mission prompt, tool calls, tool outputs, progress messages, token events, and final answers. It does not show hidden model reasoning. That is encrypted or omitted by design. For this workflow, that is fine. I am not trying to inspect the model's private reasoning. I am trying to inspect the work that it actually performed. This is the part I care about as a builder. What did it read? What command did it run? What evidence did it find? What did it conclude? If I can answer those questions, I can trust the workflow enough to use it as an engineering aid. The first lane is QA evidence. This agent is looking for proof that the game has actually completed meaningful iPhone and iPad routes. It reads the Maestro docs. It reads the full gameplay flow. It reads QA reports. It checks local artifacts. Most importantly, it checks the dual gameplay folder, builds, and dual gameplay. The result is nuanced. In the live run, the verdict is a conditional pass. In the earlier coordinator run, the verdict is partial. Those are slightly different labels, but they tell the same story. There is real QA evidence, but it is not enough to claim full release readiness. The strong evidence is that both iPhone and iPad reports reached OpenSea. Both reached progress normalized equals 1.0. The runtime is around 18-14 seconds. There are paired raw recordings, iPhone raw and iPad raw. That is nothing. That is substantial simulator route proof, but the agent also finds the limitation. Some report paths point to artifact routes that are missing locally. The proof is useful, but the evidence chain is incomplete. That is exactly the kind of distinction I want a QA agent to make. Not passed because the project looks mature. Do not fail because one folder is missing. It says, here is what is proven, here is what is not proven, and here is the risk. The second lane is App Store blockers. This one reads the release side of the project: privacy policy, support page, submission metadata, privacy manifest, release script, scanner rules, archive and upload reports. At first glance, a lot of this looks healthy. The privacy and support materials exist. The release gate exists. The scanner exists. The project has the shape of a serious App Store submission pipeline. But the agent is not grading shape, it is checking current evidence. The current audit file is builds iOS audits and iOS App Store distribution. And the result is pre-flight fail. No outputs. No current signed archive, no current upload proof. So this lane returns blocked in one run and fails in the other. The label changes slightly. The engineering meaning does not. The App Store path is not ready. This is the central turn in the video. The swarm is valuable because it challenges my narrative with fresher evidence. The third lane is process hygiene. This agent answers a different kind of question. Can this workflow safely run in parallel? Not every task should. It reads the hardening docs. It reads the Maestro QA script. It reads the release script. It looks at CI concurrency. It passively checks the process list for Unity, Xcode, Maestro, and simulator-related processes. The conclusion is the rule I would give any team trying this. Use agents in parallel for investigation. Do not run shared state build systems in parallel unless you have explicit locking and isolation. Unity, Xcode, Simulator, and Maestro share generated projects, local databases, derived data, simulator state, screenshots, reports, archive folders, and upload folders. Parallel inspection is cheap. Parallel mutation is expensive when it goes wrong. The verdict is conditional. The project documents the rule, and some scripts enforce pieces of it. But there is not one global lock that prevents every possible local conflict. That is a useful finding. It tells me the workflow is disciplined but not fully hardened. The fourth lane is artifact proof. This might be the most practical agent in the whole swarm. It asks a simple question that humans are very good at avoiding. Do the files still exist? And are they fresh enough to support the claim? The agent finds the older proof. It finds the dual gameplay recordings. It finds the QA JSON reports. It finds docs from May 15th and May 16th. But then it compares those against the current state on May 18th. And the release artifact chain breaks. No current archive folder, no distribution folder, no upload folder, no current App Store Xcode project output, no clean chain from old proof to a current releasable build. The verdict is fail or blocked. Again, not because the project has no progress, because the current evidence does not justify the current claim. That is the distinction a good release system has to make. Now the coordinator does the part that makes this a system. It waits. It does not stop at the first confident answer. It does not average the results. It waits for the evidence lanes to return. The App Store lane returns first, blocked. The coordinator records that but continues. Then the QA lane returns, partial. There is surviving iPhone and iPad root proof, but there are missing artifacts and conflicts with the latest App Store evidence. Then artifact proof returns, blocked. The freshest release audit failed, and the current archive, export, and upload artifacts are missing. Finally, process hygiene returns, partial. The workflow is documented and partly enforced, but still relies on operator discipline for some local heavy lanes. Then the coordinator gives the final readiness call, not release ready. This is the result I actually want from a serious automation system, because the goal is not to create confidence. The goal is to earn confidence. The swarm found meaningful progress. It found real route proof. It found useful release gates. It found process discipline. But it also found the gap between we have worked on this and this is currently shippable. That gap is where many projects get into trouble. The pattern is not specific to this game. If you are building software with a team, the reusable idea is simple. Use the coordinator for synthesis. Use specialist agents for independent evidence. Keep destructive or stateful operations serialized. For a pull request review, I would split the lanes like this. One agent checks tests, one checks security sensitive code, one checks API compatibility, one checks documentation and migration notes. The coordinator produces a merge recommendation with risks, not just a summary. For release readiness, one agent checks CI history, one checks changelog and versioning, one checks build artifacts, one checks deployment or rollout risk. The coordinator gives a go, no go, or conditional go. That is very close to what this demo did. For a framework migration, one agent checks deprecated APIs. One checks build configuration, one checks test coverage, one checks runtime logs or known breaking changes. The coordinator turns the findings into a migration plan. For an incident or postmortem, one agent reads logs, one reads recent commits, One reads metrics or alerts, one reads customer reports. The coordinator builds a timeline and separates symptoms from causes. For compliance or security, one agent checks secrets, one checks dependencies, one checks data collection or privacy docs, one checks deployment configuration. The coordinator gives reviewers a map of what needs human attention. The principle is the same across all of these. A swarm is useful when the work naturally separates into independent evidence lanes. It is less useful when every agent needs to touch the same file, run the same build, or make overlapping decisions. The strength is not the number of agents, the strength is the structure of the questions. So this is the workflow I wanted to show. Cursor coordinates the swarm. The agents inspect separate evidence lanes. The terminals tail the real session logs. The coordinator waits for the results. And the final answer is not the most optimistic interpretation. It is the interpretation the evidence can support. In this case, the evidence said, the project has real QA progress. It has meaningful gameplay proof. It has useful release scripts and compliance materials. But the freshest App Store audit failed and the current release artifact chain is incomplete. So the responsible readiness call is not release ready. That is why I find this kind of agent workflow useful. It does not remove the need to think. It gives thinking better instrumentation. It helps me separate old confidence from current evidence. It lets multiple investigations run in parallel without turning the build system into a shared state accident. And when it is designed well, it gives me something more valuable than a fast answer. It gives me a decision I can defend. That is the version of AI-assisted development I trust most. Not a machine that always agrees, but a system that helps me find out where reality is. I have been using agentic AI to build swarms of agents that help me iterate faster, audit my own workflows, protect the system from overloaded build lanes, watch for memory pressure, reduce disk space buildup during multi-agent development, and automate larger parts of the production pipeline. This video was one slice of that system, parallel agents inspecting evidence, while the dangerous build work stays controlled and serialized. Over the next few videos, I'll break down the rest of the workflow in detail, how I structure these agents, how I keep them from stepping on each other, how I use them for game development, QA, release readiness, and production automation. So if you are interested in practical AI-assisted engineering, agent swarms, and building real projects with these tools, subscribe and follow the journey.